Great having you, my wonderful scholars. Jam pass question 2002. Question number 3. If the distance between two suspended masses, 10 kg each, is tripled, the gravitational force of attraction between them is reduced by. Our question is centered on gravitational force or gravitational force field. Okay, to do justice to the question, first of all, we'll demonstrate confidence that we can. The question is centered on gravitational force. Recall, Sir Isaac Newton has given us an equation that solves gravitational force. And the equation says gravitational force is equal to gravitational force constant or universal gravitational constant, m1 mass of particle 1, m2 mass of particle 2 over square of the mean distance apart, the gap between the two particles of mass. You must square it. This is one of the inverse square laws. Inverse square laws compared to Coulomb's law of electrostatics. Okay, let's go back to gravity. Then observe the question again. The question says, while two suspended masses, illustration, mass 1, mass 2, each is 10 kg. Each of the mass is 10 kg. Then the gap between them, we do center to center difference or gap. The gap between them is this, R. Center to center gap. That's the mean distance. Okay? So this gap is tripled. Then the gravitational force is reduced by. Even the question understands that when the distance is tripled, the force will be reduced. Because that is what Newton portrays in this equation. You can observe that increase in force means decrease in the distance apart. In the same manner, increase in the distance apart means decrease in the gravitational force. This is what we call inverse proportion or indirect proportional variation. As the force is increasing, the gap is doing what? Reducing. Anytime the gap reduces, there will be a kind of increase in force. However, when the gap increases, the force will do what? Reduce. The gravitational force becomes smaller. Inverse proportion. They don't go in the same direction. One is going up, whereas the other is in what? Going down. Even the question understands that when we triple this gap between the two masses, then the force is meant to reduce. Then let's say it will reduce because that's the question. So let's solve. Okay, then let's see. We maintain our formula. F is equal to G m1 m2 over. Remember, the question says that the gap is tripled. The gap is tripled. The distance between the two masses is tripled. This is the distance. This shows the distance. Then see what I'll do in this new equation. I'll go and triple it. 3 times r. The distance is tripled. But recall, Newton gave us a pattern for this variation. It must be squared. So we've observed what the question demanded, or what the question demands. The question demands that the gap must be tripled. We've observed that. Then let's now see the impact on our force. We need to solve further to see the impact of this gap tripled. When something is tripled, that thing simply means that the variable is being multiplied by 3. For instance, if I'm owing you 100 naira and the money is tripled, I'll pay you 100 times 3. That is 300 naira. So synonymously, this gap is tripled. That becomes 3 times r. They record the pattern. This is the standard for the formula. It must be squared. That's why I maintain the square. Then we solve further. So we can see the impact of this gap tripled on our force. Let's push ahead. Then solving further, we have capital G m1 m2 over. Then laws of indices. Each of these variables will pick its own square. That becomes 3 square r square Mathematically, that's what you obtain. Okay? Capital G, M1, M2 over 3 times 3 is 9. 3 squared simply means 3 times 3. 3 is squared. 3 times 3 giving us what? 9. Okay? Then R square is maintained. Then observe something here. Then let's find a way to bring out our initial formula out from the new formula. See what I mean by that? Observe here. Let's scrape out here. What I just scraped out there is the gravitational force itself. That's the formula that defines gravitational force. Then there's a new inclusion there. That new inclusion tells you how much force is reduced. Then another way of putting this formula is this. F is now equal to 1 over 9 times, then I can now put what I've scraped off. Capital G, M1, M2, all over R squared. Observe, those two are the same. Then what does that tell you? This is our force. This is our gravitational force. It has been reduced by 1/9. So this is a reduction that happened in the force. Our force is now reduced by 1/9. Anytime the gap between the two particles of mass is tripled. When the gap between two particles of mass is tripled, the force will be reduced by 1/9 of its initial value. That's what we're proving following this mathematical principle. Please stay tuned as we push ahead. Observe the options. The best option there is option B that says 1/9. Thank you. Please subscribe and stay tuned.